The hook for today has to do with a fountain which is throwing or projecting water into the air, and I want to make it go 4 times as high. So what should I do with the velocity that's going out of the nozzle? Should I make it 2 times as much, or 4 times as much, or 8 times as much, or 16 times as much in order to get the water to go 4 times as high? If you would go ahead and make a guess at that and put that on your quiz. And then the second item on your quiz, how fast is the water going upwards at the top, that it's shooting up, being a fountain, and at the very top, how fast is it going upwards? If you would put that answer, and feel free to go back to those answers that you put and change them as we go through this lecture, and you decide that a different answer would suit you better. Again, it is not something that you are to consult anyone else about. We will talk about it in class, but you should not change the answers that you have at that time. So, I want to talk about free fall, and this is perhaps just a matter of you guessing what it means to be free fall. Well, I'll tell you. Free fall means falling freely, that is, without anything holding you back. No parachute, no wind blowing upwards, no drag force. So that's what is meant by free fall. And that falling with the only force acting on you being gravity is going to be free fall. And so what do you think about the answers for item U here? Oops, and I kind of gave this away, but you can see if you were listening to me or not. Also, would you answer this question? Why do we call it free? Why is free fall free? This has to do with if you love something, you let it go. You set it free. So maybe that's the right answer. This is just a problem I wanted to expose you to before you did some homework problems, that a ball is thrown upwards, projected at 15 meters per second, straight up, and how long will it take to go 5 meters up? Well, if you take, I want a displacement of positive 5, the initial velocity is positive 15, the acceleration in this flight is going to be negative 9.8, and the question is how much time? And this is the obvious equation that unites these 4 items, but you see it is a quadratic equation in time, and so there will be 2 solutions. When you solve, I make this homogeneous by subtracting these 2 from both sides, I get an equation which will have 2 solutions, and they will be 3800ths of a second and 2.7 seconds. So the question, and I would like you to answer this on the quiz, is how can it be that there are 2 answers? How can there be 2 different times to go 5 meters up? And it might be helpful to you as you take that on to think about this appearance of that flight. I throw it straight up. Here it is 5 meters higher. Why are there 2 times for it being 5 meters higher? And that ought to be not too great a challenge to answer that question. But please do. Here is another problem, a different problem. Suppose the problem was, how long does it take to go 500 meters up? And again, you would put the same initial conditions, except that instead of delta x being 5, I want it to be 500. This quadratic has no real solutions. It still has 2 solutions, but they're both imaginary. Well, what does that mean? that there are no real solutions for the time to go 500 meters up. And finally, if instead of going 5 meters up, you ask it to go 5 meters down, so instead of a positive 5, I put in a negative 5, but the same initial velocity and acceleration, again we get a quadratic. Always a quadratic will have two solutions. This time they are both real solutions, but one of them is negative. The question to you is, what does this mean? That it takes negative 3/10 of a second to go 5 meters down. Think about this picture of a projectile's flight with some variations and see if you can answer that question as well. When you are doing projectile problems, to project is to throw something. What will the vertical velocity be at the very top of the flight? And I know this is redundant, but it's an important idea, so go ahead and answer that and put that on the quiz. How does the time to get to the top compare to the time to get back down? See what you think about an answer to that question and put it on the quiz. Finally, this is not a question for you to answer, just a statement. At equal heights, both on the trip up and the trip back down, the speeds are equal, not the velocities. At one point it's going to be going up and the other point it's going to be going down. But the magnitude of the velocity, the speed at those instants, are going to be the same. Equal height, equal speed. These might be very useful to help you in doing projectile problems. And then we have a whole bunch of problems that you're not supposed to see now. But here is the first. A ball is thrown straight up. What is its velocity and acceleration at the top of its flight? Please choose between these four answers. A ball is rolled up this ramp and then it rolls back down the ramp. We're taking positive to be in this direction. So which one of these 5 graphs represents the acceleration for that ball, which goes up the ramp and then rolls back down again? Please answer that on the quiz. And finally, this is not a problem that you need to answer on the quiz, but you have the option. This is for extra credit. That marble is rolled across the table. It's rolling on the table, and then it goes onto a piece of felt that's 30 centimeters wide. When it has rolled 20 centimeters on the felt, its speed has become half as much. And the question is, if that's the case, will it make it across the felt before stopping? And the acceleration is constant. To just answer that question will not get you extra credit. I would need to see work. It would need to be work that I could understand. So it needs to be both neat and lucid. And please lay it out completely, and I would happily lavish extra credit upon you. If I really, really like what you do, I would give you, go crazy, Houghton, 3 points. But I have to really like not only your answer, but your sharing with me how you got there. Okay, that's big bucks. You won't usually get 3 points for extra credit. Do it. Take it to the bank. Finally, a discussion of graphing. This has nothing to do with what we've been talking about, but when you do graphs for me, there are several peculiarities that I'm going to insist upon, and if you decide to do it your own way, I will take off points, because I will call it wrong. The first thing that needs to happen in a graph is it needs to have a title which tells me what was done to generate the data. Just any old title is not good. It needs to be a title which I could read it, and then I would know, oh, there was this cat, and it was climbing a tree. And this is showing what was going on for that cat climbing a tree. This is not easy. It's like an English assignment. It's like, what did I do to generate this data? And then how can I tell someone what I did? It's a big communication challenge. The other second thing that I would like graphs to do is to have their axes labeled, not only with what is being graphed on that axis, but what the units are. And that goes for both axes. Just writing hours here is not as good as saying that time is being graphed on this axis and the units are hours. I could argue with you that just writing hours, you might be measuring angles, that we take or if you wrote minutes or seconds, definitely, maybe hours. But if you wrote minutes or seconds, I could say it was an angle, because we divide angles into fractions that are minutes and seconds. So put time and then what the units are. The last issue that I have is that if there is a trend to the data, you must indicate it. It will not do for you to give me just a scatter plot of all of these data points unless there is no trend to the data, in which case you ought to leave it a scatter plot. But if there is a trend to the data, you need to draw it. And you could decide that a straight line fits this data better. That's okay. We can have arguments, but there must be a statement of what you feel the trend to this data is. And when you draw that trend, you are stating that this is what was really happening. That line represents what was really happening. The fact that these data points are not on the line, I would say, is it because of random or experimental error. So if I were to ask you, where was the cat at 12 hours, you would not say that the cat was at 300 centimeters up. That is flawed data. It's got random error in it. Instead, I want to know the truth about where the cat was, and you would give me this value from the trend line, which I would read that graph to be that that's 8/10 of the way. I'm not sure if I feel that way right now. It looks more like 7/10, but this answer I have here claims that that's 8/10 of the way between 300 and 400, and remember that you can read a measuring instrument to 1/10 of the smallest division. That completes the lecture for today.